Hello! Today we will see how to transform a Y connection into a delta connection and vice versa, and why it is so important for some network analysis. If we have such a bridge circuit, we have the problem that to simplify the circuit we cannot use the parallel formula because these parallel resistors are linked with a serial resistor, and we cannot simplify with the serial formula because these two serial resistors have some link and from the inner node to some other point. To solve such kind of problems, we need the delta-to-wye transformation. These three resistors build a delta connection as we see here. And if we can now transfer this delta connection in this Y connection, we can simplify the circuit. Now we have here and here true serial connections. The two passes build a true parallel connection, and this lower and this higher part is again a true serial connection. More about how to calculate serial and parallel resistors you will find in the video 009EN. Today I will show you how to derive the formulas to transfer a Y circuit in an electrical equivalent delta circuit, and how to transfer a delta circuit in an electrical equivalent Y circuit. The Y connection and the delta connection are electrical equivalent when the resistance between the node 1 and 2 in both circuits are the same, when the resistance between node 1 and 3 in both circuits is the same, and when the resistance between node 2 and 3 in both circuits is the same. With these basic thoughts, we can now generate the following three formulas. The resistance R1 plus R2 is equal to the resistance R12 in parallel with the resistance R13 plus R23. The resistance R2 plus R3 should be equal to the resistance R23 in parallel to R12 plus R13. And finally, the resistance R1 plus R3 should be equal to the resistance R13 in parallel to R12 plus R23. With the formula for parallel resistors, we can transfer these three equations into the following format. R1 plus R2 is equal to R12 times R13 plus R23 divided by R12 plus R13 plus R23. The same for the other two equations. Now we multiply R12 with the element in the brackets and sort the resistor values according to their indices, and we will get R1 plus R2 is R12 times R13 plus R12 times R23 divided by R12 plus R13 plus R23. And we do the same for the other two equations. Now we want to get the formula to transfer a delta connection into a Y connection. What we need is R1 is a function of these three resistors, R2 is a function of these three resistors, and R3 is a function of these three resistors. If we subtract from the first equation the second equation and add the third equation, we will get here on the left side R1 plus R2 minus R2 minus R3 plus R1 plus R3, and we see R2 and R3 are removed and we have 2 times R1 on the left side. Luckily, we have on the right side on each formula the same denominator, so we only need to write a big fraction bar with the denominator, and on the top the numerator from the first formula minus the numerator from the second formula plus the numerator from the third formula. We will do now the following three calculations. First equation minus second equation plus third equation, then second equation minus third equation plus first equation, and finally third equation minus first equation plus second equation. Here are our three calculations. For the first calculation we get 2 times r1 is numerator from the first equation minus numerator from the second equation plus the numerator from the third equation divided by the denominator. Now we see that some parts can be removed. Here we have plus, minus, plus, minus, and we see that r12 times r13 is 2 times available, so we can also stroke away later the 2 times and 1 of this, and we do the same on the other two formulas. So finally we get r1 is r12 times r13 divided by r12 plus r13 plus r23, and the same for the other two formulas. In general, we can say the Y resistance of a special node is the product of the delta resistances of the same node divided by the sum of all delta resistances. In the special case that all the delta resistances are equal, all the Y resistances must be also equal. With this simplification we will get Ry is R delta divided by 3. Or we can say, in case of symmetry, the Y resistance is 1/3 of the delta resistance. Now we want to derive the formula to transfer a Y connection into a delta connection. So we need these three formulas. R12 is a function of these three resistances, R23 is a function of these three resistances, and R13 is a function of these three resistances. In the first step we divide equation 1 divided by equation 2, then equation 2 divided by equation 3, and then equation 3 divided by equation 1. We will get R1 divided by R2 is numerator of equation 1 divided by numerator of equation 2, and the two denominator cancel each other. Now we can remove R12 and get R1 divided by R2 is R13 divided by R23, and the same is valid on the inverse. R2 divided by R1 is R23 divided by R13, and the same can be done on the other two fractions. Now we go back to this formula and divide the numerator and the denominator by R13, and we will get R1 is R12 divided by 1 plus R12 divided by R13 plus R23 divided by R13. Now we can replace these two fractions with the one we have already calculated and get R1 is R12 divided by 1 plus R2 divided by R3 plus R2 divided by R1. We do it in a similar way on the other two lines. In line 2 we divide by R12, and in line 3 we divide by R23. Now we bring the denominator on the other side and multiply each element with R1 and get R12 is R1 plus R2 plus R1 times R2 divided by R3. In principle, this is the formula we are looking for, but usually it is written in a little bit different way. Therefore, we extend R1 and R2 with R3 and bring it on the top of the fraction bar and get R12 is R1 times R2 plus R1 times R3 plus R2 times R3 divided by R3. And of course we do all this calculation on the other two lines. Here are our three formulas to transfer Wye resistance into delta resistance. In general, we can say the Wye resistance is the sum of the three products of the two Wye resistances divided by the resistance of the Wye resistor on the opposite node. In the special case that the three Wye resistances are equal, the three delta resistances must be also equal. With this simplification we will get the delta resistance is 3 times the Wye resistance, or in case of symmetry the delta resistance is 3 times the Wye resistance. Today we have derived the formulas to transfer a Wye connection in a delta connection and vice versa. In part 7 we will use the transfer formulas to do some calculation of a bridge circuit and calculate the diagonal resistance of a cube with a 10K resistor on each edge. That's all for today. If you like my video, give me a thumbs up and subscribe my channel. And to be informed about new videos, activate the bell. See you in the next video. Bye bye.